Hey, how's it going? We're ready to talk about chapter 2, and this is about matter and change. So, we're actually starting to get into more chemistry, whereas before we were talking about just the basics of science. So, let's get started. So, why do all samples of a substance have the same intensive properties? And I do want you to know the difference between intensive and extensive, and we'll talk about that in class as well. I think this is something some students struggle with. So, is the substance dull or is it shiny? Is it a liquid? If it's a liquid, does it flow slowly like some honey, for example? Or does it flow quickly like water? Does the gas have a smell to it, or is it odorless? Does it have a color? All of those would be some properties we might observe with our eyes. So properties are used to describe matter that can be classified as either extensive or intensive, and you again do need to know both of those definitions. Extensive properties matters to what extent do I have that substance? How much do I have of it? So something like volume and mass would be extensive. One basketball weighs less than 10 basketballs, etc. And so mass would be one example of an extensive property. Volume is also an extensive property. One golf ball or one basketball contains or is a smaller volume than 10 basketballs would be. Or the mass of one or volume of one golf ball would be much less than one basketball. So, extensive properties, volume and mass are both extensive, and it's a property that depends on how much or to what extent do I have that sample. Intensive properties are things that are independent of how much I have of something. And so a property that is intensive would be color. Doesn't matter how much I have of that sample, it always has that same color down to the very one thread of a piece of fabric will still have that color. So, identifying substances. So you do need to know intensive versus extensive, and we'll do more examples in class. Matter has uniform and definite composition is called a substance. Something like aluminum or copper wires would be examples of substances, and these are actually pure substances. There's nothing else there. If I have a copper wire or aluminum wire, it is 100% copper or aluminum. Every sample of a given substance has identical intensive properties, and that's based on its composition, not on the amount I have of it. So every piece of copper wire will have the same density, whereas they will have different masses and different volumes. Hardness, color, conductivity, malleability are all physical properties. And these are something that it is a quality or condition of a substance that can be observed or measured without changing the substance's composition. You have something like this in your textbook, and I'm not going to ask you to memorize something like this, but I will ask you to use it. So, you have a substance that is let's say, liquid at room temperature, and it has a reddish-brown color. What is the substance? Well, we would look at the state of matter, and we'd see, well, it's either ethanol, mercury, bromine, or water, because those are the only that are liquid. And since it's reddish-brown, it must be bromine. So, not too bad. Physical properties help chemists identify substances. Forensic science is all about identifying samples, comparing it to a known sample, and identifying what that substance is. And we can use various physical properties to do that. We could use density, We could use boiling point, melting point, color. So we use a lot of physical properties to identify substances. We use glass to make windows, but we don't use copper for that. We use that for wires. And why do we do that? Well, because the physical properties of the substance helps. If we choose that substance wisely, we can have a really good property. So glass is transparent. We can see through it. It's hard. It won't let the rain or the hot in very well. And so we use it for windows. But to put it in the window frame, we need something else. So we use usually a plastic or metal to be around the outside of that window. So a lot of chemistry is finding the right kind of material for a certain application. So you may want to compile a list of properties of a substance, but you don't have a way of measuring the mass or volume. What kind of properties could you use to determine without knowing the amount of matter in the sample? Well, you can determine its intensive properties, and that would help us identify the substance. What are the 3 states of matter? And actually there are 4 states of matter, but we are going to focus only on 3 of them. And I'm sure you've known this from a long time ago. We have solid, liquid, and gas. The 4th state of matter is called plasma. And plasma is where we have a high concentration of charged particles. And usually it's like very, very hot. Solid is, and this, you need to know these definitions. So you need to know that a solid has a definite shape and a definite volume. It doesn't depend on the container that's placed in. It is independent of that. So a solid has the same shape and volume, or defined shape and volume. Examples that I typically use are something like ice cubes or any other solid like a diamond, a ring, a desk. All of those are solids. Solids is a form of matter that is a definite shape and volume. I don't know how often I can say that before you'll actually remember it. They are also incompressible. It means I can't make them smaller if I press on them, whereas I can make like a gas smaller if I press on it. They expand only slightly when heated. Liquids. Particles in the liquid are in close contact with one another, but they are not in a rigid array like a solid is, where every atom is in a particular spot. The particles in the liquid are free to flow or move around, which means that a liquid will take on the shape of the container. So it has a defined volume, but not a defined shape. So it has an indefinite shape, it flows, and yet has a fixed volume. Liquids are mostly incompressible. You can compress them slightly, and they do expand slightly when heated for the most part. Gases are like liquids in that they take the shape of the container, so they do flow. But unlike a liquid, a gas will expand to completely fill the volume given to it. So it will expand to completely fill the volume. So it has no defined shape nor a defined volume. So in this case, we see a container, and this looks to be probably bromine atoms. And they are further apart than in a liquid. And there's more space between the particles, and therefore gases are easily compressed into a smaller volume. Word vapor and gas are sometimes used interchangeably, but they are not the same. And you do need to know the difference between gas, which means that it is like oxygen would exist as a gas at room temperature. However, water does not exist as a gas at room temperature, but it is a vapor at room temperature. Today in August, it's very humid, and we can feel the moisture in the air, and that is water vapor. That is not water as a gas. A substance that is in a state in which it takes the shape of a container, what would it be? It could be either a liquid or a gas. And I would know which one it is if it completely filled the container or if it just took on the shape of the container. Physical and chemical changes. This one's very difficult for some students. How do we define a physical change? During a physical change, some properties of material change, but the composition of the material does not change. If I take a piece of paper and I rip it in half, I have changed its physical size and shape, but I have not changed that it is actually paper. Words such as boil, freeze, melt, condense, cut, break, split, grind, crush all indicate we've done some kind of a physical change. And you might want to write most of those words down. Physical changes can be classified as either reversible or irreversible. If I rip a piece of paper, that is an irreversible change. But if I melt a piece of ice, I can then refreeze it if I wish. And so some are reversible and some are irreversible. Physical change involves a change from one state to another state are reversible. However, things like cutting hair, etc., would be irreversible changes. So as water boils, becomes a vapor, this is a reversible physical change because I could then turn it back into liquid water if I reduce the temperature. Oh, we're at the end of this section. Every sample of a given substance has identical intensive properties because every sample has the same composition. The three states of matter I want you to know are solid, liquid, and gas. Physical changes are classified as either reversible or irreversible. Here are some of your vocab words, and again, you do need to be making a Quizlet set so we can play Quizlet live. Here's some more vocab words. Yet some more. And lastly, our big ideas that chemistry is a central science. Physical properties such as melting point and boiling point are used to describe matter. And that is the end of this section. Thank you. I will see you in class.